Oh, hello. I didn't realize you were there. Well, if you just saw this video, then I have two cars here, and you just saw me basically driving these cars on this ottoman. So, what we're doing here is a related rates problem that has to deal with these two cars. This one we'll call car C, and this one we'll call car D. Now, what we've been doing here is basically we've been using this ottoman right here, this ottoman, to essentially act as our road. Now what I'm taking here is this car C goes at a rate of 90 kilometers per hour, which on this ruler is a scale of 30, and I'm using a factor of 3 as my scale. And then we have here car D, which goes at a rate of 120 kilometers per hour, and I used it as 40 centimeters, which if you multiply by 3 is 120. So what we have here is the digital representation of our problem. We have a right triangle, and we have C right here, which shows 90 kilometers per hour, which is car C. And then we also have car D, which is 120 kilometers per hour, which is essentially the distance going. Now this is just a digital representation of a scale of 10. And the question we are asking is, how much is the distance between the two cars when they are increasing at a rate of 5 hours? And E, which would be our hypotenuse, is the distance, I didn't want to do D because of the fact that we already have a car D, and another D, which would represent distance, would be, I think, a little bit redundant in our matter. So since we're dealing with a related rates problem, we have this right triangle here to show us that car C is going at 90 kilometers per hour, and car D is going at 120 kilometers per hour, and the question asks us how much is the distance between the cars if it's increasing by 5 hours. So what we have here is basically C squared plus D squared equals E squared, which, if you know the Pythagorean theorem, is essentially that derived formula. Now what we have here is 5 times 90 added to 5 times 120, which equals E squared. And if you want to just, let's look that up and see how it works out. You could definitely do out the math. But anyway, we're going to do it this style. So in this way, what we're doing is product rule, essentially using 2 times car C with the derivative of car C with respect to time, plus 2 multiplied by car D times the derivative of car D with respect to time, which gives us 2E times the derivative of E with respect to time, which is basically our distance that the two cars are traveling at a rate of 5 hours. So if you were to essentially reduce that by a factor of 2, you would essentially get the same answer of car C being multiplied by the derivative of car C with respect to time, plus car D multiplied by the derivative of car D with respect to time, and then you have your answer of E, which is our answer being multiplied by the derivative of the distance with respect to time. So now what we do here is essentially we have to square out both of the numbers, our derivatives, because it's imperative that we do this in the sense that the Pythagorean theorem basically tells us we need to square out the numbers. But we also have to make sure that we also don't leave out the 5, because the 5 hours is the rate of change in this problem. So if we add them together, we get 562,500, which, if you want to see the extended form of it, we have 450 squared, which equals 202,500, and then we have 600 squared, which is 360,000, which equals 562,500. So basically, what we now have to do here is essentially we take the two numbers that were given. We basically have to multiply our car D which is multiplied by the derivative of car D with respect to time, and then we take D, which is also multiplied by the derivative of car D with respect to time. We divide that by c squared plus d squared, which is both the cars, square that out. And if you can see this is essentially what we're doing to find our area. We're using the quotient rule pretty much on this. And the entire answer equals out to 750. And then, since we're done with E at this point because we found that answer, but if we want to go further to find the derivative of that distance, we need to divide it by 5 because we have a rate of 5 hours. So dividing it by 5 will give us 150. So the derivative of the distance between the two cars with respect to time is 150 kilometers per hour. However, if you take into account that it goes after 5 hours, it's 750 kilometers